Hi, everybody. We'll continue chapter 3, and we are in 3.3, which is the chain rule. This is one of the important rules in this chapter of differentiation rules. So I will explain it and do more examples. And of course, we'll target some more examples even in recitation to make sure that everybody knows this rule. Chain rule is also used in conjunction with the rules of differentiation that we saw and developed. So here is kind of, and here we call it rule number 7. So if you have a composition of a function, so if you have h as a function, which comes from a composing two functions. And we did the composition of function, something like this. So it is in this order. And of course, you practice on this. In this case, to find the derivative, you have to use this other part of f prime, otherwise you won't be correct. And in some occasions, you can move away without using the chain rule. For example, you can multiply. For example, here, you have f of x, x plus 1 times x plus 2. You can, let's say, or let's switch it this way. Let's make it this way. You can, for example, say, okay, I can switch this to 3x plus 1 times 3x plus 1, right? And FOIL. Then, so let's do it. Then I'll explain a little more the chain rule. So you have 9x squared, you have a 3x, you have a 3x, and you have a 1. So 9x squared plus a 6x plus 1, that's f of x. Then you can find the derivative by doing the power rule for this first one. So it'll give you 18x. And this is a multiple 6 with x, so the derivative of x is 1 and plus 0, right? So you can go do it this way. But in some occasions, it's not possible or doable. If this 2 is a 50, 100, a 10, so we're not going to multiply this 10 times, right? So and in some occasions, it's not possible. So the solution to this problem is the chain rule. So the chain rule says that if you have a function composed with another, you can take the derivative of the outside. So look at g, it's the outside. And f of x is the inside. So this is how the composition is done. You have a g of x, which is the outside function, and you have f of x, which is the function that was substituted inside g of x. So that's the inner, inside or inner, right? So when you do the derivative, you do the derivative of the outside, and you substitute the function inside, right, times the derivative of the inner part. So it's not bad. It's kind of a direct formula. Is all we need to know is the order. The order matters. If we switch it around, it won't be accurate. So you'll get questions in this way and that way until everybody really recognizes that this has to be done in this way, in this order. So Leibniz did this notation, and this notation is powerful. And let's write it here. Notation for the chain rule. Came up with the simple idea that I'll explain how it works. he just said that if I want to take the derivative of the y with respect to x, I can actually do it in a chain, dy over du times du dx. And the idea is simple. Of course, if you think about, if you have 5 over 6 and you put 5 here and 6 here, you can put what you want on this side as long as they match. You can put, let's say, a 7, right? For example, as long as they match, because if they cancel, you get 5, 6. So that's how you would remember this, du. So you can differentiate the function y with respect to u, multiply with du with respect to x. So we'll see this in examples. So if we go back to the example to explain chain rule, we'll find that this is using power rule or just like the previous, because previous rules, and now using a chain rule. This is going to be a chain rule connected with the multiple rule, and not the multiple rule, the product rule, and we'll see it. So square. We need to break this down based on what the definition says. So we need to ask, when we did this composition, how did we compose this? So this is just, until we understand what happens, then we don't really have to do it each time. You can just apply the chain rule, but we need to understand how it happens. And we did this previously in the homework, and that's why we did it. So we needed to recognize that there was a function, a 3x plus 1 function, right, that went inside another function, which is the x squared, right? So that's what Leibniz didn't use one as 3x plus 1 as the and the other as du. But just to stay without yet getting to that formula or notation, we can just think about it the way we did this in the past. So f of x is a function 3x plus 1 went inside x squared function, right? So the g of x is this function, and f of x is this function that's inside, all right? So you do the derivative of this one, and you put this one in it, then you do the derivative of this one. So what does that mean? So this is how it would look like. You will do the derivative, and let me show you this formula now that we have to do it, which is the power rule with the chain rule. So in the past, if you have x squared derivative, you just do 2x, right? So now it's no longer that way, because we have to generalize this formula. So you see n, so we do the other way. We say this is x squared, and prime, it's going to be n, which is a 2. The function f is x, 2 minus 1, times the f prime, which is the x prime. So that's how this was done in the first place. It was anyway using this chain rule, but we did not stress on it because it was just easier to do it without stating it. So it was, what is the power rule is just n times whatever it is, x, n minus 1, right? And we finished it that way. But now when this is not x, when this f of x is not x, you have to show what that derivative is, because when it's x, it's just 1. So in this case, when it's not x, it's 3x plus 1, we have to do 2 times 3x plus 1, 2 minus 1, times the derivative of the inside. So you will have a 2 times 3x plus 1. The derivative of this one is 3 times x, which is the multiple 3. Derivative of x is 1, so 3. The derivative of 1, a constant, is 0. So it will give us a 6, 2 times 3, 3x plus 1. Distribute, you get 18 plus 6. And as you see, the two answers match. So if we can use the previous rules and it's easier for you that way, it's fine, you can do it. But in some occasions, you cannot do that. You have to use the chain rule, right? So in this example, of course, we do a few examples where we demonstrate that you can verify the other way, but there are many examples where that's it. You can't use the previous methods anymore. So we go back now and talk a little more about this. So keep in mind, if this is the outside, then the derivative of the outside with f of x, this is the inside, it remains inside times the derivative of the inside. So the chain rule works in outside to inside. So we can write that note here. The chain rule it works outside to inside, right? And this is just to explain what the Leibniz notation, and we can do some examples using it. So, but for now, the one you're dealing with is like the chain rule with the power function, and we explain it here, and we'll do some examples on it. So let's look at this example that's included here. If you have 3x plus 1 squared, similarly, right, and I worked on that example already, so you can check here how it's done, the steps, and you can pause the video and compare, and when it's used the other way, how it came up, right? So now let's do some examples from lecture activity 3.3. And we're going to look first at the first question. So for example, if you have f of x equal 6 minus x to the fourth, what is the derivative? Of course, this is, if you want to use the power rule, it's no longer accurate to say 4 minus, let's show it on this first one, 3, that's it. So remember, this is not x. If it was x, that's it, but it's not x. So you will need the inner function derivative, right? Which means you need the 6 minus x derivative, or the f of x. Right, so 4 times 6 minus x to the third. And the derivative of the 6 is 0, and this one is -1. So it gives us -4 6 minus x cubed. That's it. So now for a second one, let's say you have a function with respect to time, and you have a 6 times a t to the fifth minus 4 all power 5. 6 is a multiple. So you see, we still use the previous rules. We don't ignore them. 6 is a multiple, so it will remain on a side as a multiple. Now to do the power rule on this, so this is a power rule with the chain rule, right? So power rule with a chain rule. So we do a 5 times t5, 4, 5 minus 4 times now the inside. All right, so that's the inner part. That's going to be here, t5 minus 4 prime. So it's 30, t5 minus 4, 4. And that's, now you see the power rule, 5t 4 minus 0, of course, constant. So we don't write it anymore. We skip it, that part. Skip that part. So somebody will say, why you didn't use a chain rule on this? Well, I'm differentiating with respect to t. So that's like the power rule. So t to the fourth, if you do dt to the fourth with respect to t, we're differentiating with respect to t, then it's the power rule. It's 4t to the third. Even if you want to do the chain rule, you need to do t prime, right? What's t prime? So t prime is dt, the derivative with respect to t, which is 1. You see 1, this cancels with this, it's 1. So when you differentiate the x with respect to x, and when you differentiate t with respect to t, they are 1. But when they're not same, when you differentiate y with respect to x, you can say 1 because that's dy over dx. All right, so now we multiply 30 with the 5, so 150. And t to the fourth, and t5 minus 4. That's it. So you see, it's not bad. It's just a matter of using the chain rule in a correct way. And now we're dealing with it when it comes to the power rule as well. So let's look at the homework 3.3 and let's say number 2. So this homework is usually given, is broken down, so you can work on each derivative and see how to use it, which makes the work kind of simple. So we just did like this one, right? So g of x, as you see, it's this inner part. H of x is just with the power 4. Then you have a multiple. So just to show you, when you take these parts and you find their derivatives, it makes it easier when you apply the rules, right? So that's how usually you'll be doing them. So 3x squared minus 1. And here you can do it here, or you can do it the next part. So 4x cubed minus x to the third, and you need the derivative of the inside, right? X cubed minus x derivative. So you need 4x cubed minus x cubed, 3x squared minus 1. So now if you want, if you need f of x prime, 6 is a multiple. So it's just like what we did, similar to this example. And now times the derivative of this, which I just did here, which is h prime of x, right? So 6 times 4 times x minus x cubed minus x, 3x squared minus 1, 24. And these can remain in this form. We don't need to FOIL them. All right, so we can look into if there are some other examples that are different. It looks like, let's say number 3, f of t is a square root of 6t squared minus t. we learned that this is same as to power 1/2, the 1/2 power. So similarly, if you want to differentiate with respect to t, you do the power rule that is combined with the chain rule. So you see the inner part not changed, but 1/2 minus 1 times the inner part derivative. So 1/2, and now we change this to 2/2, so it becomes negative 1/2. And this now it's just the power rule, 12t minus 1. So this is dt dt power 1, right? So on the side, keep in mind that you're doing this. So 2t dt dt, if you use the chain rule, that's canceled. So chain rule can always be applied. That's, you know, from today you can always use it, even in the simple stuff. But if you realize the simple stuff is simple, you don't have to use it. But if you use it, it's not wrong. It will actually give you the correct answer. So for just this one here, you know, then you have a 6 outside, will make it a 12. So dt dt, you know, just that's 1. Right, so that's how that came up. So now we can just say this is 1/2. We've done it. So at the denominator we have this, numerator we have 1, we have this. So it's 12t minus 1 over 2, a square root of 6t squared minus t. All right. Of course, for number 4 now, it's similar. You're gonna do make a power rule with a chain rule, so it's similar process for number 4. And let's look at number 5. It's actually similar to number 3. The only difference is we have a cube root, so we just need to recall what the cube root is. So f of x is 5 over 7 t squared plus t. Of course, you look at this exponent here, it's 1, so it's 1 over 3. All right, so this 3 comes here, 1 over 3. And if it's that, then it's 5, 7t squared plus t negative 1/3. So once you prepare it, once you put it in this form, then it becomes now familiar. So now we can differentiate with respect to, so here it's not correct. If we have t, then it's f of t, not x. And that's it. So we do 5, it's a multiple sitting there. We do n is negative 1/3, 7t squared, this negative 1/3 minus 1. Then the derivative of this inside part. So negative 5/3, 7t squared minus t, which will give us negative 4/3. Then this is 14t minus 1. And that's it. Now we need a negative 5 is on top. A 14t minus 1 is on the numerator side. And we have 3 on the denominator. This has a negative exponent, so we will come here and have a positive exponent. So this is okay. or if we want to write it as a radical, because we started with the radical form. This 3 is outside a cube root, and 7t squared minus t to 4. But I would just leave it maybe this way because that's fine. But you know, if you want to type in the other, is okay. All right, so number 6. Number 6 is going to be similar to what we did. The only thing similar to what we did, it just we need to remember that if you have f of u, if you have a sum of two functions, that you still need to do that rule of the sum, right? Which makes it easier because you differentiate each one. So if you have f prime of u, and you have a sum of two functions, which we did, and we've done now so many times, anytime you have 3x plus 1, what is the derivative of this one? Is the derivative of 3x plus the derivative of 1. It's a 3 plus 0, it's 3, you know, so, something like this. So this is we've been doing all the time. So the derivative of this function is going to be the derivative of g. Then you work on it by itself, then you do plus, and you work on the derivative of h by itself, and you do that plus that one for your answer. If you see that they don't combine, they have weird stuff, then you leave them as they are. You just write them as a sum. So let's look at something that's different, than probably a little bit different. I think we can do number 7. Yeah, 7 is a little bit different because it has a product rule, and we have to use also a chain. So number 7 states that you have a function with respect to u, and it has a square root of u plus 1, so I will switch it to u plus 1 to 1/2, and multiply by 1 minus 5u squared to the 6th. So I have a product, and that tells me I need to do a product rule. You see, it has nothing to do with the chain rule. If you have a product, you use a product rule. Then you see what happens. So this is just like if I have g of u, and this one, for example, if it's h of u, and this is like if it's like q of u. So if you have this thing, when you do the product rule, you're going to do this first one times this, add, and do this one, all right? So that's how the product rule works. And now we can just go ahead and do each one by itself. So h of u is just u plus 1. Now q of u is this one here. So you need to do on the side this derivative, or you can do it here. So let's do it in green. This one, like a green one. So how would this one work? This is a chain rule. So q prime needs a chain rule. So chain rule is 6 times 1 minus 5u squared 5, just like a power rule. But we need the derivative of the inside, you see. So that's q prime of u. Then we need to add q of u, which is just what it is, multiply by h prime of u. H prime of u. So h of u is u plus 1. So 1/2 times u plus 1 1/2 minus 1 times the inside derivative. Let's do that so it doesn't look like 1. All right, so let's continue. U plus 1, 1/2. So the way this question is given to you is you do these derivatives first separately. So when you set up this formula, then you start substituting your answers for these derivatives, and you'll get what I got in this line, right? So now the green one, we will have a 6 times 1 minus 5u squared 5. This derivative here, let's do it this way, so it's derivative. Derivative 1 is 0, derivative of this is negative 10u. Right. So plus, then 1 minus 5u squared 6, then a half u plus 1, 1/2 minus 1 is negative 1/2. Derivative of u plus 1 or derivative of u with respect to u is 1. All right, so now we can just do g prime of u for the answer. We have negative 10, we have a 6, so negative is 60u. We have a u plus 1 to 1/2, so that's a square root, and we have to the 5th, right? So that's that first part, plus here we have 1 minus 5u squared to the 6th, and we have a square root of u plus 1 and a 2. All right, that's it. So we leave it in this form because there isn't much to do, make it complicated. All right, so yeah, so when you work on it, just be patient with it and do each part that you have, each function, you do each derivative, do each chain rule on it. You set up the product rule, right? Once you set up the product rule, it's just a matter of substitution and simplifying, and we get the answer. We can try number 8, which is g of u, 7u squared over u squared plus u cubed. So of course, think about it as you have f of u over p of u. So you can, of course, on the side, to set up the derivatives. If this 7u squared, that means the derivative of it is going to be 14u for the derivative, right? So for this bottom one here, in the denominator, you will do 3u squared plus 1 squared. Then you need the derivative of the inside, which is a 2u plus 1. And that's going to give you the derivative of that. Then, of course, it doesn't matter what these are. This is a quotient. So we need a quotient rule, right? Which would state that you need p of u times f prime of u minus f of u times p prime of u, and this is the bottom is always that function denominator squared, which is let's just keep it as p of u now, and squared. All right, so this is the setup. So as I mentioned again, it doesn't matter what it is. There is a quotient rule that applies, and this is the quotient rule, and this is how it applies. Now it's a matter of course, this is a prime. It's a matter of substitution, and we just go ahead and apply them, right? So this here is u squared plus u2 cubed times 14u minus squared 3 times u squared plus u squared, and this is u squared plus u. It's cubed and it's squared, right? So that's gonna become, it's gonna become u squared plus u to the 6th. All right. So we have a 14u times u squared plus u cubed minus 21 u squared times u squared plus u squared times 2u plus 1 all over u squared plus u 6. So this is going to be probably the most challenging one because now that you get to this form, when you look at it, of course, the thought is to start distributing and multiplying, but of course, let's use the pencil here. If you see that, if you start this distribution, then you have that to FOIL with this, it's gonna be a big thing. And of course, you have this one. So one thing to do in these type of examples, so one way to do is not to multiply, but try to simplify. If it's possible to simplify, it will be better. Because if we try to simplify, it will make it easier. And how do we simplify? Of course, we're going to look, is there something to factor? Anytime we talk about simplify, we factor. So if you see there is a u here and there is a u there, which means we can factor one u from these two. So we have two groups here. We have this group and we have this group. So we're going to look at what it is common to factor between the two. We have a u, so that can be factored. What else? You see this u squared plus u to the third. It's u squared plus u to the second. So two of them can be factored. We can factor u squared plus u to the second. 21, 14, no factoring there. 2u plus 1, no factoring there. All right, so this is an important thing to have and skill to know. Anytime you use the quotient rule and you have some giant thing, the idea is to try maybe to simplify will help better than just try to multiply everything. So so doing that, we can factor, we said we factor 1u and factor a u squared plus u squared. When you do that, what's left from the first one, the first group? You'll have a 14 and u squared plus u 1. It has 3, 2 are out and 1 is left. There were 2 and now 1 is out, right? And now there is 1 left. Here there was 1, none left there. And we had u squared plus u here, 2. They're out, they're no longer there, right? But there is this 2u plus 1 left. So now compare this, when you write this, compare it with what we did in the previous step. So I'll show it again. So let's show that again. So you need to write these down to practice them and write the first group. Do it manually so you see everything happening. And when you do that, now you see that the new group is this, that first one, and the second group now is this. And this what was factored, what was common and was factored. So let's look at simplifying. So look at u squared plus u squared over u squared plus u to the 6th. Yeah, we can cancel a 2 with the 6 there, right? So a 2 from there leave you a 4. So that tells us that 4 will be left there and none here. So, but the u is still there. So none are gone. So if you wonder what happened, that's what happened. So we simplify that. So we have 14 u squared plus u. And I just put these ones here to show that they are 1, but we don't need to put them, not to confuse with prime or something. So 21 u times 2u plus 1. I just simplified the denominator. All right, so simplified the denominator. All right, so now we can go ahead and multiply. We have 14 u squared plus 14 u minus 42 u squared. Distribute that minus 21 u over u squared plus u to the 4th. And we combine these like terms, we get negative 28 u squared minus a 7u over u squared plus u4. And as you see, this is can be factored. And if it can be factored, so this is good. That's a final kind of answer. But since it can be factored, we can go ahead and factor a negative 7, because there is a negative and negative, and a 7 in there and a u, right? So if you factor a 7u and you have already a u there, so that's going to be a negative 7 times u, and that's going to change this 4u to plus 1 over that denominator to the 4th. So the final answer will become a 7u squared 4u plus 1 over u squared plus u to the 4th. So yeah, so it's a matter of following it to the end, simplifying it. Now you have a new, if you haven't used these skills before, you've seen a skill where you make sure you simplify, you factor and simplify in the middle, so you make it easier to process. And then that allows us to simplify further the denominator, and we go ahead, multiply, combine like terms, then we look at the answer and say, is there something else to do to it? In this case, yes, you can factor a negative 7u, which will make it negative 7u squared. And because we took out a negative, they are going to become positive inside 4u plus 1. And that gives us a final answer there for that one. All right, so we do one more and we'll finish this thing. Number 9, which is a unique example. It says if you have, if f of 0 is 3 and f prime of 3 is negative 4 and g of 0 is 3 and g prime of 0 is 6. And H is defined as a composition of F composed with G. So we know that F composed with G is F with G inside. So if we use X, it will be F of G of X, right? So now the question will be, for example, what is H of, I think of 0? So I'll just double check, but it should be that. Yes, so H prime of 0. So now the question, what is H prime of 0? So as you see, no formula is given for f of x. No formula is given for g of x, right? So you're going to say, how can we do this? But we know that H is a composition, F composed with g of x. So if you want the derivative of this, you're going to apply, so we need to apply a chain rule. Applying the chain rule, look here, it's very important to notice, not to memorize, but to notice and apply. If we memorized that g prime f of x times f prime of x, as we had in the beginning, it would be incorrect, but if we memorize it works outside to inside, we will still be correct. So the outside is f, so f prime of g of x times inside g prime of x. So we're talking here about 0. So x becomes 0. When x becomes 0, we substitute it and we just chase it. So what is g of 0? G of 0 is 3. What is g prime of 0? It's 6. So we can substitute these inside. Then it's like opening parentheses inside out. All right. Now we need f prime of 3. F prime of 3 is negative 4. Times 6 will be negative 24. So this allows you to further reinforce the definition of a chain rule, further understanding it and understand how it works. And regardless whether you have a formula or not, you could have a chart, you could have graphs, and you read these numbers from the graphs. But the chain rule does not change. You work it outside to inside, and that's it. So try these examples. Let me know when you have questions. Thank you.